Oh boy. There was, you know, during the time of construction is what you're talking about, where
Yes, sir.
or you transition to the new chillers?
Correct.
Okay. Um, I'm not sure how much. There's probably some limited notes here regarding it.
So maybe the site plan is a better representation that you had. So we know where the existing line is, you know, thought to be from the as-built conditions and some previous surveys that we have. So yeah, whether this connection in grade, you know, this is the expectation of what exists out there, whether this is connected with whether the chiller plant can kind of remain in place is one question from a enabling standpoint. And if it cannot, then, you know, if there's temporary chillers, temporary units that are, you know, parked in Gasparilla Drive and they make a new connection at this spot, like maybe this connection still has to be maintained until the project's fully complete.
Or another way of looking at this, Dave, is if you want to make this T and you're trying to remove the underground piping, and you want to have an option for routing above ground, you know, this is the intercept point, I guess, is what we're saying to backfeed it.
Understood.
Okay. Anything else, Steve?
No, that was it. Thank you.
All right. All right, I'm gonna stop sharing and turn it over to Ron. Ron, you can go ahead.
Yeah, I gotta pick the right screen here. Let's see.
Yep, we see your
You
screen.
see it?
Yep.
Okay. So for the electrical distribution, on the site, there's going to be some existing panels here over in this location right now for the park. And those panels are going away. And eventually, I think this is still kind of in the works, some of the site stuff with the panels in the dog park and some of the areas going on up here. But currently, right now, there's some panels up here that belong to the city. And we anticipated relocating them down here. A lot of this stuff that's feeding from the park up here will go to the new panel location. But again, some of this is, I think, still in the works and being discussed or changed.
Well, so I'll just give you the background. So basically, the northwest corner of the site being up in the park, that's all
Yeah.
part of the park's power system. So what Ron's describing is those panels that service that northwest corner, and they backfeed some of the other areas. To Ron's point, they are getting proposed to be put in that location. The Parks Department has approved it, and we don't think there's any other hurdles to note, but we just have to go through the permit process with them, make sure it's okay.
David, I think it's just important to note, and I'm sure everybody knows this is Curtis Dixon Park, very active with events and other things going on. So they'll be definitely looking to our team to provide them with a plan of how this work is going to get done, and the schedule and phasing, so their operations are not interrupted. I think Wasteman Freight and TLC have already done a good job kind of identifying what's going to be going down and where everything's being relocated. So just kind of the next step of taking it to a sequencing plan and getting parks comfortable with the construction schedule.
Yeah, and that's a great point, Zach. And you'll notice, I think there's two different panels, and one of the panels is dedicated solely to this area up in the top. So it's like, you know, there's not a real challenge of that because it can go offline completely. The other one's a little bit more complicated, and then down where we're proposing to put the new panels, there's actually the existing junction box for where all the feeds come through. So it's co-located intentionally to be very close and, you know, to minimize any kind of site work that needs to occur. this, yeah, right where that number 4 is where the existing junction box is.
Mhm. So as David mentioned earlier, this is the yard, current chiller yard, and the generator's out here right now. And that generator is going to move over into the building. And here's the site plan with the proposed new generator, or the transformer, utility transformer, TECO. Currently, right now, I think over in this area right here, this transformer right here and a switch feeds the existing museum, this part. And we're going to put in a new transformer to and this will go up to the second floor main electrical room with the main switch. This right here is a remote generator cabinet, and that'll go up underground up, and this will go up to the third floor where the emergency distribution gear is at, to tie in for a roll-up generator.
Hey, Ron, this is Zach.
Yeah.
On the existing generator, just so Beck's on the same page, the existing generator that's by the chiller well that it
Yeah.
feeds the museum is used to, in case of a power outage, to really power the museum and keep the HVAC units running, to keep the artwork and the safe environmental conditions. And I think there's some other stuff. I was curious, Ron, if there's a similar to what Dominic showed the detail about the temporary chiller tie-in. Is there something similar to that for the generator? When we have a downtime between the generator now and the new generator?
We don't show a phasing plan for the temporary switchover to keep the systems maintained. It's
But
not
to-
showing that, David. I don't. I
But
think
to
we've-
Zach's point, the current, I guess maybe it's a little bit lower. Like if this is the chiller yard,
Mhm.
the line does still run in, and then it does run up the chases. So this chase that's kind of to the north of the restrooms is the backbone for the existing building.
Oops. Yeah.
So it'll be a conduit that's buried underground, and if there needs to be kind of a splice connection that's made to intercept that for temporary conditions.
Right, for temporary conditions, right.
Okay,
That could
so
be
we
done,
don't-
but we don't specifically call out any of that on the drawings, but that's a process that could be done. Yeah.
Okay, so we can work with Beck, together to kind of come up with that sequencing plan.
Right.
Great, thanks, Ron.
Yeah, and to Ron's point, these, we know how much, duck banks cost and premium that's put on them. So what we tried to do was locate these kind of central to this east core of the new project, the staircase and elevator, and to run it up along the south side of it, so that both they don't overlap each other, but also that they can run straight up through the building uninterrupted, and there's no offsets or anything. So it goes below the staircase, but to the east of the elevator. So there's a little bit of coordination in terms of the conduits themselves and their elevation, but we think that it's probably the cleanest way to get it up into the building without having to do a lot of sweeps.
Yeah, and this is a straight shot, a dedicated chase right up to the second level to the main electrical room. It's got the board, main switchboard. And as far as power goes, we've split the plans up for power, meaning this is kind of general power. And then as you see the AV. So this is just general power. It's generally the first sheet with nothing on it. And then as you go with the AV, this is dedicated to the AV systems. And then this with a T on the end, this will be dedicated to the theater systems. So as far as the electrical distribution goes, we broke it up into having the normal power distribution and then kind of branched off a separate system to serve the 4 different kitchens, and then another distribution system to go for the AV distribution, and then another set for the theater. And that's all kind of spelled out here. Like here's the kitchen. This is all served. That whole board serves the kitchens. So it'll go up, serve the kitchens up there, serves the kitchens over here, down here, and down here.
There's a likely scenario where the museum has a tenant that they will meter their power and water usage. So that's kind of
Yeah.
the idea of separating these.
Yeah. And there's a meter. There's a meter on the kitchen, main kitchen panel. So and there's a distribution system here for the AV. You see it's coming off here and serving the AV panels. And the same with the theater system, just showing how it comes off the main and feeding the theater systems on the first floor and second floor mezzanine. So I think that should be it pretty much for the power. And then for all the lighting, there's a Lutron system feeding the lighting. And we do show that Lutron system being tied back into the existing building. With the renovations, there was a Lutron system in there, so that's getting tied back. And as far as the electrical distribution on the emergency side, this is feeding up here. There's going to be in the distribution line, you got the generator feeding the line of distribution for the emergency generators. This right here will tie back into the existing generator distribution system. And there's already conduits from the renovation. There's already conduits installed from that existing board. It's stubbed out right near the board, and it's feeding over into the existing mechanical.
Ron, do you show that connection location on there, on the plan view?
Yeah,
You might go into that real quick.
it's fire alarm.
On page 11 of 57. Ron. So
11?
essentially,
Okay.
on the ground floor of the existing building, the existing emergency power connection was extended. It's in the upper plan. So keep going up. I think what you're referring to is
Oh yeah, there it is. Yeah, it's coming up the stairwell, and then it's it's shooting over to the other side. So
Well, can you pan down just a little bit? I can draw for everybody. Just a little bit more. Yeah, so there's the existing mezzanine right here. And what Skanska did was they ran their conduits to the face of the building, and they left them empty conduits so that when you guys open up and create this soffit condition outside the building, you'll be able to just connect into the existing conduits there. We have survey points that we can provide of and some photos of the existing conditions to kind of give you guys a better understanding of where we expect them to be. And yeah, we'll go from there.
So I showed them. Overlap.
So that's it for the power and the lighting, and then there's the fire alarm system. That is also, there's going to be a new fire alarm panel taking care of this expansion, and then it gets tied over into the existing, which is in the main security room.
That's the same connection point.
Yes.
Yeah.
Yeah, there's a new security room in the expansion, and there's a existing security room where it's a simplex panel. So it'll just be tied. It'll be tied together so everything communicates. So other than that, I think that's about it for a high level overview.
Yeah,
Is
let
there
me.
anything else you can think of, David, or?
Yeah, I just want to share my screen real quick
Sure.
to show you guys a few subtleties. So, Ron's talking about the electrical, and part of our job was to coordinate the audio, visual, and the theatrical system. So I want to speak to that just a little bit. So the museum is using obviously the expansion as an event space programming. So here's the second floor event space, but also on the ground floor, there's that auditorium space. And then on the rooftop, there is a outdoor event space and indoor event space. In the second floor in particular, this is the example I want to show. We have this identification of busport BP 1, 2, and 3 on the project. And what that is it's this light lab busport system that's I mean, a couple companies make it, not many, but it's basically a combination unit of data can be applied through it, power, and it can also be used as a strong point for suspending equipment for theatrical events or artworks. So in this project, we utilize this light lab product. There's a couple of different sizes to them. So like when the museum expects just to hang art, we don't necessarily have all the AV and technology inside of it. But then in like the event space on the second floor, they kind of have and you'll see in the drawings, they have a grid of these bus ports, and this is showing the AV bus ports. And then every other one, like if you overlay these plans, every other one is a theatrical one. So you're never going too far away from having capacity to use the theatrical system or to use the AV system, but we don't force them into the same system and like balloon them to be too big. So this kind of bus port happens on the ground floor in the lobby space, and it happens on the second floor. There's also this component where the museum wants to keep flexibility for events to occur that they don't know necessarily what the program requirements are. So there's bulk power. And Ron, maybe you can talk about these are like industrial level 100 amp plug connections that are happening. And we've identified them on the second floor. They're happening kind of around the perimeter of the space so that the museum can let a basically anybody can come in and decide that they want to host an event on the south side of the room, the west side, the north side, or the east side. So it's like museums interested in this flexibility, and this bulk power happens up on the roof, and it happens even outside the building, where they host events in that stepped terrace area. And then the last complex element that we've spoken to previously is this video wall, which Ron has coordinated with our AV team, the power and data requirements for this kind of system to work. So this has all kind of been engineered out. But we're happy, like if we need to have a dedicated call about this kind of system, I can get our AV team to be a part of that. I think that's for me, those are the kind of the big overlaps that you'll
Yeah, and
see.
there seem to be a lot of 60 amp plugs distributed around. I know there's out in the terrace, out in the site, out in that common event space. So just quite a few of 60 amp plugs.
That's right. And then in the auditorium space, there is a pipe grid above the performance stage, which has, the power and data distribution. But that's kind of a standing pipe grid that's not utilizing the busport system. That's just using a standard pipe system. Okay, I'll stop sharing. Is there any questions for electrical before we move on to plumbing, fire protection? Okay, Scott, are you on today?
Yes, David, can you hear me?
Yep. You want to take the screen?
Yeah, sure. Give me a second. All right, can you guys see my screen?
Yes.
Okay, cool. Yeah, so I did plumbing and fire. The plumbing and fire systems are a little bit more straightforward than the mechanical and electrical. The plumbing is almost entirely a separate system. The fire protection is fed from the existing building. So kind of like, here's the existing building here. Similar to the mechanical, the fire pump is located on the first floor mezzanine in the existing building. And this doesn't show all the internal routing of the existing building, but we provided, there's like a main that goes down here, and we provided a provision in the renovation for the new system to be extended from the existing. And that fire pump here has enough capacity to feed this new expansion. It's pretty simple. They got a 4-inch main, show risers in each stairwell that then go to feed the sprinkler systems on the floor above. We did show a fire protection layout, but we also provided a reference note that this is mostly for coordination and pricing only. It's somewhat of a note to you guys, but also to the permitting official, because I know in the past we've got flagged for that, where they're looking for contract, fire protection, sprinkler contractor drawings to serve as those record drawings. So everything here is shown pretty much for coordination, especially like Dom had mentioned on the mechanical side, there's a lot of low tolerance ceiling spaces. So just to make sure that the constructability, there's a route for that we can get some of this piping in here. And then in the sprinkler heads, we're somewhat coordinated with, ceiling layouts and things like that to make sure everything kind of flows. I think this, so similar to mechanical as well, there's not as many, but there's instances we show on drawings where we show dimensions from grid lines and an elevation of bottom of pipe for in reference to level 1, where sleeves are coordinated with structural penetrations. So there's like one here, looks like one here, and a couple over here. I think it's the bulk happens on this level 1 mezzanine, fire protection wise. But outside of that, pretty straightforward. We don't have any special. It's just a wet sprinkler system, nothing special. On the cover page, we list out our 61G with all the design requirements. And that's pretty much it. Are there any questions, or David, do you want to add anything as it relates to fire protection?
I think the only thing I would highlight is, there's this existing riser in that west core, and the expectation is that there's a valve there, and there's currently an empty pipe that's extended to the west. So the expectation is you're not ripping up, this whole ceiling to get to this, that this pipe should have a stub out right at the curtain wall.
Any questions fire protection wise?
Oh, here's one little component, just for Beck's reference. So the building is compartmentalized. So when Mechanical was talking about the smoke and whether there's any exfiltration devices, we were able to avoid that by having the two buildings separated with a 2-hour rated wall system. So on the second floor, there's a glass wall system, and on the ground floor, there's also a glass wall system that kind of separates the two buildings. So here on the right-hand side, I'll just circle it. Here is the glass partition, the 2-hour rated partition, and then downstairs, there's a partition right here. You'll see that avoids us from having to have a 3-story connection and having to exfiltrate the air and the smoke. But what it does mean is like it's compartmentalized so like there could be a fire alarm event on the east side of the building or the existing building, and the sprinklers could be engaged, but it wouldn't trigger the west side of the building. So it's just like it's a programming item, but it's the two buildings from a fire alarm, fire prevention operate separately.
Okay, and then I guess if there's not any questions, I'll just move forward towards plumbing. So like I said, it's mostly self-contained system. We're getting a new cold water feed for the building. We have separate sanitary, separate storm connections to civil. We're gonna have a grease interceptor out here, an underground storage tank for the generators in that mechanical well. We have some risers for those fuel pipes. The one connection is we have an existing gas meter here, and we're gonna connect downstream of the meter. Connect here, feed this underground where it's dashed, come around, and then rise within the building. And there's like a riser location here. We have some other systems. Okay, so I guess starting with domestic water, kind of taking it system by system, it's rising in the building here, and then it's rising to the 3rd floor where we have our I guess the 2nd floor mezzanine, where we have where is it? We have our plumbing room here. This is where the booster pumps are. This is where the gas water heaters are. So the gas water heaters are going to feed the hot water, and there's like a recirculation pump for all the kitchen hot water requirements, and then the booster pump is going to feed the cold water for the entire building. The bathrooms have their own hot water tanks at each bathroom within the janitor closet adjacent to it. So it's kind of the water's going to go up to the 3rd floor and then distribute down and throughout through these risers in this general location. So I'll go back to the 1st floor and kind of work my way up. So this is underground, a lot of this is for the kitchen, bathrooms, and then we're just gonna exit the building.
Can we stop there for a second? So for Beck, and this is for Beck and Ellison advisors. So essentially we've developed a kitchen layout system with our consultant team, with our food service team, kind of getting feedback from the museum, what they think. And all of this set has been kind of coordinated to that level. So all of the systems and all the recommendations, the museum will be in talks, if they're not already, with food service vendors and providers that are going to be operating this building. And there's always a chance that that they want to make changes to what the museum had, and the museum makes changes. So this coordination, obviously, it's something that we need to keep on the owner's radar, because we've had experiences in the past where changes are made so late that they balloon potential costs. But for everyone's reference, this is kind of the latest and greatest. It's coordinated, and we think it's a successful kitchen that they'll be able to use.
Yeah, and most of like right here on ours, on our like the plumbing drawings in general are we have a lot of enlarged views. So like all the kitchen layouts will be shown in our enlarged, similar to the bathrooms. The overall views are mostly shown for like mains routing, and so this is the general riser for the building, or one of the riser locations. You can see up here we have some sanitary and storm, and then in this one similar, sanitary, storm, grease waste, so our gas is rising. But so I can flip through these overalls. They don't show a ton, because a lot of it again is captured in the enlarged. The overall will show a lot of the storm coordination, and this was heavily coordinated because it's sloped pipe with insulation coordinating around ductwork and structural. So here likewise we show dimensions off grid lines, we show bottom of pipe, sleeve sizes. This was all previously coordinated with structural, so will need to be tightly followed in the construction. Here's where, so we have two riser locations that go up, and then they kind of meet here on this floor to go down. This is not much is shown up here, just the riser for the fuel oil. This is just condensate. So on this floor, it's shown because this is mostly a kitchen above, our kitchen on this floor, but above this is our mechanical room. So we do show the floor drain and the hub drain, sanitary and condensate piping on the overall. And then likewise up here, we have a roof above this, the mechanical well. So this is where a lot of this is. The storm that's serving this is shown. We show our fuel oil system exiting here, kind of routing tight, and then going up to the generator on the floor above. We show this fuel pipe as double wall within anytime it's within the building, not in a rated chase. Second floor mezzanine. So here's where the bulk of all of the storm is. Same thing, heavily coordinated. Not only with structure, but we also have a lot of AV no-fly zones. So this is even more.
Yeah, so what Scott's referring to is, those bus ports that I was describing to you, they retract up into the ceiling. You push them up into and lock them in place. So they have cables that actually move with them. So basically the bus port systems attached to steel, and then as they slide down, they straighten themselves out. But as they get compressed up into the ceiling, the cables and the conduits, the flexible conduits kind of can bow out. So basically the manufacturer says like they could bow out this much. So we kind of identified at each one of these bus ports a no-fly zone for Scott and the whole TLC team, which I'm sure they all appreciated.
Yeah. Yeah, that's why there's all these, offsets and things like that. They're not totally arbitrary.
And that's just like a 1 foot, 2 foot in diameter, kind of around that bus port, pretty much is what you're describing, David.
Yeah, it's rectangular. So it's like
Okay.
the conduits kind of go in like east-west directions and not north-south. So it's a little tighter in one direction than the other. So we oriented them. So the orientation is actually quite important to consider as well. And you'll see that in our Revit model that we shared. I think our boxes, they might be hidden as like a component, but they were modeled with that kind of no-fly box.
Got it.
So here on the second floor mezzanine, we have electrical room, plumbing, IT, AV. So mostly electrical and IT, and directly above this is a kitchen. So we have a general note that any piping serving the kitchen above, that is we try to coordinate anything so it would be like center of room or try to exit as quickly as possible, not route anything directly over any panels or anything like that. But we want to provide drain pans underneath any piping with alarm monitors if there is some sort of leak that's detected.
And Scott, there should just be drains, right? They're not pressurized systems. It's just a drain
Correct.
system that's in the
Yeah.
electrical rooms.
Yep, correct. Yeah, it's this all this piping here. It's most of it comes directly south and we try to route our mains outside of it, but not all of it was avoidable. So okay, so that's pretty much that floor. These are just storm routing to try to get from the floor above to down below. Here's our roof drains that underneath the chillers and the generators in this mechanical well. Here's where our fuel pump our fuel return pump is for the fuel system in the generator. So this is showing level 4, the roof terrace. And so we show roof drains here, but then we have a canopy above. And so that's where you see some of this piping here is serving the roof. We have roof drains on the canopy above. And then they are routing into the building and then down this one of these. This is like the general, like for our gravity systems, like these 2 locations are the general riser locations for our systems. We try to keep it somewhat consolidated. And then the pressure systems are typically into that location there.
Yeah, and we kept these 2 kind of storm risers on the north side of the building to kind of minimize the pitch and the impact to coordination. And then as Scott showed earlier, they kind of come together where we have a double height space in the loading dock. And then they go back down into the ground out into the building or out of the building.
These are just showing those roof drains on the canopy above. And then we get to our enlarged. You can see this is a typical, not to go through every one, but this is a typical bathroom. Nearest janitor's closet is feeding it with hot water. We have a mixing valve station, recirculation pump. We show electronic trap primers for all the floor drains, things like that. Pretty typical. Typical kitchen, like, we're showing this is all this hot water is being fed from that 3rd floor, those 3rd floor gas water heaters. We show gas going to the hood system and then just whatever appliances needed, I guess. Yeah, these are just typical enlarged coupled with risers. This is our kind of an enlarged of our plumbing mechanical room, and then a little ISO for it. Here's our overall. So this will exclude everything that's detailed in the enlarged, but this is the overall routings of the mains and the different systems. This is our roof storm system. Some generic details. That's pretty much it.
Scott, do you want to talk about the generator's tank, the fuel tank and its location outside the building?
Yeah, so we show this 6,000 gallon underground storage tank. I forget off the top of my head, I have to check with the manufacturer, but there is like we want to keep this as tight to this stairwell as possible because there is like a minimum or a maximum distance we can run this without that the pumps can handle. But basically, yeah, it's 6,000 gallons. We have inside here, I show, let's see. So here it is. So we show this is our filter system. This is our supply pump. So the piping will come in, go through the polisher, go through the pump it up to the generator, and then the generator likewise has a return pump to pump it back down to keep everything moving when it's not in operation.
So this is like a
Well-
small little service room we've located, tucked it away behind the elevator on the ground floor. So it's, this is an exterior door, so it's but this would just be servicing the pump system for this. And we've done, you're right next to the garage. So, the placement of this tank was coordinated with kind of the existing foundations of those columns for the garage. So it's kind of located for both efficiency and to work around the existing conditions.
Yeah. All of it was, I know it was all modeled, I believe, around Simplex, the manufacturer. So the elements we have in there are modeled, they're just generic boxes, but they're modeled to their general dimensions. But yeah.
I think that covers, there's, typical things like convenience hydrants and things around the project that the owner has requested. Small little things like that. And but yeah, I think from a high level, that is the plumbing system and fire protection.
Any questions?
I think all good here on the backside. I think when you got into it, you said the plumbing and fire protection seem a little bit more straightforward than the
Right.
mechanical and the electrical side of things. But yeah, it looks good.
Cool.
Greg,
Right,
do you want to
David.
talk? Yeah, Greg, do you want to pull up your stuff for security and technology?
Yeah, let me just, I don't know why my computer decided to freeze, so hold on a second.
I can share mine too. It's not a big deal.
Yeah, if you want to do that, my computer's, it's being funny, it won't open Bluebeam.
So I can give you
Oh,
the high
actually-
level. You want to go and just jump in, Greg? That's fine with me.
Yeah, that's fine.
So
Go ahead. Do you want me to talk, David, or you gonna?
yeah,
talk?
you go ahead.
Okay, so this is the site plan for the technology. So what we're doing is we're gonna be utilizing the existing conduits coming from the MDF that's located on the level 1 mezzanine, down underground and into the existing communication vault. At the communication vault, we're gonna provide 2 new 4-inch conduits that are gonna run underground over to the expansion and then turn up. And then on the higher floors, you'll see it going up to the 3rd floor. I believe that's what it's considered, right, David? I don't recall the level.
Yeah, it's the second floor mezzanine space. So
Second floor
it's-
mezzanine,
yeah.
so they'll turn into, I'll go to the floor below. Okay. So they'll turn out and into a cable tray. And then they'll run in the cable tray and then turn up into the IT room on the second floor mezzanine. If you can go back to the site plan. We're also running the conduits for the access control and door operator underground as well, as it's all glass walls. So there's really no way to go up all the way to the second floor ceiling space. So all that's going to run underground as well as the door operator motors are underground as well. So all of that will connect underground.
This branch that Greg's describing has primarily its technology and security purposes. But there is also a connection between the existing building and the expansion for their AV system. So there's an AV rack system in the mezzanine of the existing building. And just to have kind of, I guess, dialogue between the two buildings, there is a hardline connection through this conduit system.
Yeah, we can go to the next page. So real quick, overall, first floor, data drops, access control, intrusion, all of that. Any data that is part of the AV system will be on the AV drawings. This is just the museum's low voltage system for their network. Anything AV related will be on the AV drawings. So, just to kind of keep that in the back of you guys' mind, that there'll be two separate systems, the AV network and the low voltage, museum side, day-to-day operations network.
This is the new security room. So the museum will have the existing security room, but this will also be utilized. So they might like overnight, like after hours of the museum, they might all move over to the security room for while the event is happening. The museum's gone through the security camera locations and the security line of securities for card readers, like all of that's been worked out with the owner. So I think Greg's drawings are at a high level of for that scope.
Go to the next floor. So this is all the devices for the second floor. And yeah, same thing. And then we also show conduit pathways on this drawing as well.
So this is the mezzanine space of the ground floor, and along the south side of the auditorium, there's electrical rooms, technology rooms, you know, like a little office space for the technicians that are operating the auditorium. So as Greg's describing, there's you know, this back of house vestibule space has got some you know, accessible ceilings. So there's a junction box for the connection for power and well, power's over here, but for the data connections that come across to these various racks and systems.
More low voltage systems, pretty much duplicating, you know, just going through each floor. It's all really the same, and cable tray pathways and all of that have been coordinated. No, I agree. Yeah.
And one of the things that I'm gonna identify here with Greg's drawings is, you know, we described how this is like a 2-hour rated wall system to separate the two buildings. But from an occupancy standpoint, you know, the two buildings do discharge into each other in an emergency situation. So, you know, the door systems have been thought out quite extensively at this location to like really consider like, okay, when somebody panics through this door, it sets off the alarm that goes back to the, you know, so it's everything is kind of it's supposed to trigger, you know, it is a risk. The museum understands that, you know, their galleries can make a connection, but they should have a security staff on hand all times so that if somebody does have to panic through this, that the security is available.
More wireless access and data layouts and access control. Same thing with the upper floor. We have rack elevations, the telecom room, and large plan layout. Nothing really crazy. And then we have the interconnection risers between all the different systems throughout. For grounding, the intrusion, distributed antenna, and then just a bunch of details that correspond with the drawings as well.
Greg, do you want to talk a little bit about the existing museum's security system and the expectations of building on that into like what the work you did with the renovation and how that's expected to be translated into the expansion?
Yeah, sure. So the part of the renovation portion of the museum, they completely replaced their access control system and their intrusion detection system. So all of that has been just replaced and upgraded to the preferred manufacturer and all that. So the specs are there's no option for substitutes. They want to keep everything the same. As along with CCTV. So all the systems in the spec cannot be changed. So that's one of the main things. But everything has been recently updated, so there shouldn't be any surprises, and all the devices should still be available to expand on, as it was just completed recently.
So the racks and the existing systems were,
Well, they're not in the rack. Well,
Oh,
the
sorry.
CCTV system is in the rack, but the access control and intrusion, all that's wall mounted equipment, but it's all been replaced.
and
new.
it was sized, the existing systems were sized with the expectation the expansion was coming onto it.
Correct. Yeah, everything was designed knowing that this expansion was gonna be coming.
Any questions for the technology side, security side? Okay, so it sounds like, I mean, I think that covers all the disciplines we had from TLC. I'm happy, I've got our architectural drawings. We can go through any kind of specific conditions. Do you guys have any questions about as it relates to this?
And like we could,
Yeah,
all right. Good deal.
thanks for,
Thanks for TLC for you present your design, and we appreciate your time. Hopefully, I think it's been helpful for everybody. Very good.
Yeah, I think this was really beneficial. I saw we started recording as well, so we can make sure we get that out to. I don't think Michael Hallaby was able to join, but I'll send him the recording of this and see if he has any questions on it as well.
Very good.
Yeah, I'll send it right over as soon as it finishes, you know, records and sends out.
Yeah.
And then just as a heads up for Beck, I think you guys all are aware, but our MKA got called out today. So I think we're pushing the meeting until tomorrow at noon. And the invite should be updated for you.
Okay, perfect.
All right, great.
Thanks, everyone.
Thank you.
Thank you. Bye.
Thanks.
Thanks.
Thanks.